The video that we're going to be doing this time is over the perpendicular bisector theorem. You already know what perpendicular bisectors are. If you recall doing the construction manual, one of the things that you had to construct was a perpendicular bisector. So we're just going to add a little bit more information to what that perpendicular bisector is and what it means for different problems. So the perpendicular bisector theorem says if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what I have here already is a perpendicular bisector. You can tell it's perpendicular because of the 90-degree angle. That is a very important point. We know that there are two 90-degree angles here, which means it's perpendicular. The two lines here obviously means that those are equal, so it is a bisector. So it's saying that if there is a point on the perpendicular bisector, so let's put a point on the perpendicular bisector, and we'll put it here. Okay, so there's our point on the perpendicular bisector. Then that point is equidistant from the end points of the segment. So I'm going to draw a line that goes from point A to the point I just created, and from point B to the point I just created. So what we know for sure, absolutely, is that these two are congruent, because if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Now this holds true no matter where I put this point. So if I put the point here, and I draw a line from A to that point, and then from that point to B, it's the exact same thing. We know that these two lines are congruent. So the way that this is used is you're generally going to get some type of a question where they tell you a piece of information and you have to go from there. Alright, so if you look at the one in the top left, we're going to do this one first, you'll see that we have a triangle and we're told that this is congruent to this, and I'm going to add that there's a 90-degree angle there. I'm going to add it to the other one as well. Now, once you know that this line is congruent to this line, and we know that this is perpendicular, we know that the line going up and down is a perpendicular bisector. Since the two lines of the triangle, the two sides, go from the end of the line being bisected to the same point, those two lines have to be congruent. So you know immediately how to solve this, which is we set them equal to each other. 5n minus 7 equals 3n minus 1. So we're going to solve for n. I'll do it the other way. I'm going to add 7 to both sides, and I'm going to subtract 3n from both sides. Those cancel out, and I'm left with 2n equals 6. Divide by 2, n equals 3. So if I want to know what each of these sides is, then I do 3 times 3 minus 1 gives me 9 minus 1 is 8. Now, look at the one on the bottom right. So we're going to move on. Look at this one. Now, this one is a little bit different. They're telling you that these two are congruent and that this line is coming down at a right angle. So we know that this line is perpendicular, and we know that from here to here is the same length as here to here. That is enough to tell us that this is a perpendicular bisector. Now, if this is a perpendicular bisector, it means that these two lines have to be congruent as well. So, solve it the same way. 9x minus 18 equals 3x. I'm going to subtract 9x from both sides. Negative 18 equals negative 6x. Divide by negative 6. I now know that x is equal to 3. So if I want to plug in and find out what my lengths are, I know that 3 times 3 is equal to 9. And if I needed to know the whole length of this one, then it would be 18, would be this whole length. Alright, so make sure you go to the questions document and answer the questions.